Hello guys, and welcome again to Programming Funny. Today our main thing is a programming machine. So we'll talk about what exactly is a computer, what is a CPU, what is memory, how CPU works, and what is the different architecture of CPU, about the types of programming languages. So it is important and I will tell you why. Firstly, CPU and memory, it is like number 2 and 3 in my agenda, is one of the main resources of every software engineer. It means that when you will work with your application, the CPU and the memory consumption is very important, and you will every day checking metrics about the usage of these resources. Also, today we will talk about how machine do run your applications. So it is important because as a software engineer, guys, you should know how to run application with a good performance. I mean, how to run quick and more or less stable applications. And without the understanding how machine do run them, it is impossible. Also, today we say a few words about compiled and interpreted programming language. What is the differences between them, like pros and cons of both. And after that, guys, I will share with you a few things from my experience about what is good to know in this perspective. So, let's go inside the machine. So, let's talk about what is inside your machine. On this slide, you guys see maybe the main components of your PC and the main components you will work with. The first one is input and output. It is I/O. Okay, I believe that applications have no sense without input and output. It is exactly the place where you can, like, the humankind, you can see the output of your application, and you can give it some data as an input. So it works like this. And as an example of input, you can think about your keyboard, or maybe some kind of network connection, or some kind of files, right? And as example of output, it is, for example, your screen. Okay, so it works like this. About the operation system kernel. Kernel is a main administrator program in your operation system. So it is all about controlling the machine resources. Like if application need to allocate some port, or maybe need some memory, need to print something or use network, then application do request to kernel to actually ask for this kind of resources. Then it is a CPU. If kernel is like heart of your operation system, main administrator application, then CPU is a brain. And the main thing in CPU is that it can execute instructions. So actually it can calculate some data. And CPU is a brain. You should remember about cache and registers that like actually works inside your CPU. The cache is a place fast storage that where your application can save some data to access them very quickly. And this cache is very limited. It is very depends on CPU architecture. And registers is another blaze fast super small storage where your CPU can save the data to do some calculations on them. I will talk you more in the second slide. And primary storage and secondary storage, it is actually some kind of memory. Primary storage or random access memory is a place to save your application data, and for example application source code, machine command. Okay, So if you create any variable in your application, this variable will live in primary storage or random access memory. But after your application exit, random access memory will be cleaned up. And secondary storage is your hard disk or SSD, like a place where you save your torrents. So there you can write your files, and files will be saved like for a long term. Okay, you can think about secondary storage like a storage for a long period of time. So let's talk about CPU in the second slide. A few words about how CPU works. On this schema you can see the main schema, the main component of almost every CPU, and a small explanation of what these components exactly doing. For example, memory interface. Memory interface works to connect your CPU to your random access memory, for example. In this case, CPU can fetch some data, then it needs this data for some kind of calculation. Instruction fetcher know exactly where and how to fetch this instruction. How it works in general. CPU is a small machine that has some instruction set. For example, 2, 3 or less, more, it just doesn't matter, commands that can be executed. For example, it is some operations with memory, like move this value, for example, number 2, into some point of memory. Or, for example, do some arithmetic calculations, like 2 plus 2, okay? Or multiplication, etc. So, instruction decoder is, as I said, know how to create from some kind of binary stream your instructions for GTA 5. And what exactly it is doing. Instruction decoder able to read the instruction and what exactly to do according to this instruction. Then usually we move some data inside the registers and we ask machine to do calculation, okay, and then save the output, for example, in another register. After that, we able to move the results to some point of memory. And here, guys, is a very important thing. Maybe you know about that currently in the world we have a few main CPU architectures, like for example ARM and AMD. And we need to understand what is exactly the difference. Generally, there are two differences. The first one is that this CPU is different on some kind of physics level, you know. And the second point is a different instruction set. So it means that some instructions that works on ARM will not work on AMD. And in this case, the application that actually compiled for ARM will be not possible to run on AMD processors. In Golang, we have a cross compilation. It means that when you create your application, you able to create a few different binary files, like for example for AMD and for ARM, for Windows and for Linux. So yeah, in Go it works in this way. So you need to create a few files for every CPU architecture, for every operation system, and you can build any Go binary on any machine. For example, on your Windows, you can build a binary for macOS, for Linux, for ARM, for AMD, for Android, etc. Okay, it is about CPU, and in our homework, you will see the tutorial, like where you can read more about that. But we go into memory explanation. As a developers, we should know that actually memory we use some kind of three layers. It is a virtual memory that some kind of interface that operation system gives to us as developers to give us ability to use memory easy, because when developers use memory inside our application, we do not really care about physical memory. We just can say to machine, okay, like I need a space for 1 million variables, for 1 million length array, and operation system saying, okay, just take that, because in these things we do not work with a physical memory. And yeah, in the middle we have a map that able to somehow connect our virtual memory usage to physical memory. Okay, I will give you an example. For example, pizza delivery. In every country, independently on like what is the currency there, like what exactly country, you can call for a pizza and it will be delivered for you. And in every country, you can do that in absolutely the same way. It is what exactly virtual memory do. So gives you a simple interface, simple ability to use memory independently from what exactly this memory is, which kind of this memory. So when you start your application, you always run a process inside operation system, and virtual memory will be given exactly for this process. And as I said, thanks to virtual memory interface, you can use your random access memory, you can use your disk in more or less the same way. So for developers it is nice because we can care about how much memory we use, what do we need, what is our application logic, and we do not care about physical memory. But also as an engineers we should know about how exactly our application use this random access memory, in which way. So let's talk about stack and heap. Stack and heap is two ways how do we guys organize the memory of application. Stack is like a pistol clip. So when you push some variable inside, you will actually retrieve, get that last. You know, this stack is that what we use to call a function, for example, because input arguments of functions you call will be saved in a stack. Stack is super quick. It is very easy to allocate some space on stack, because it is no more as just move some pointer, because we do allocate space for a stack to organize our memory as a stack when we run our application. And heap is more or less whole memory of your machine, all your virtual memory that your application can use. And to allocate some space, we need to do an allocation. So we need to ask an operation system to provide us more space. And in this case, this operation will be slow comparable to usage of stack. So in general, stack is what we use to call a function or for save some small local variables or function arguments. It is blaze fast. It is no surprises, just one problem, Stack Overflow. And heap is what do we use to save a big amount of data? What do we use when we do not know how much space exactly we need, for example? And yeah, what do we have from heap is a pointer to some space, so then we can use that inside our application. And here, guys, is a very simple schema of how your application works. First of all, your application, guys, will be saved in random access memory. I mean your source code, your commands, your instruction to a CPU. And then the three ways your application will work is input output, because we need to read some data, we need to calculate something according to that, and then we need to return some data for the users. Then it is CPU, disk, and kernel. Because our application needs to give some instructions for CPU, our application needs to use input and output, and our application needs to use the disk. And kernel is what will be used for actually to ask operation system for doing something like give me more memory please, can I listen this port, etc. Then, guys, a few words about types of programming languages. First of all, we have compiled and interpreted programming languages. What is compiled? Compiled is when we have source code that looks more or less like English, and we have an application we start to translate our human readable source code to command instructions that very understandable for machine. And here is we have like two main steps. It is simple, but you can imagine that there are two. First of all, it is a check of syntax. So your application will see that all of your variables has the right names. You use only allowed like keywords, for example. Your arguments wrote in a right manner, etc. Then compiler will translate your application to some kind of application, like a first step to a machine commands. So it will be, let's imagine, assembler. So assembler is something in the middle between what understand human and what understand machine. It is an explanation, it is a view of machine commands is more or less human readable manner. So for example, here you see the image of assembler code where like text, func data or read is machine commands, but in assembler we use like human readable links, tags to explain them. And assembler was filmed in a movie like a Terminator. You see this image, it is from Terminator. So yeah, Terminator was the assembler driven. But let's talk a bit about how do we do that in Go. Here you can see my Visual Studio Code with a very simple Golang application that actually do a bit less than nothing, but we can use that to actually check how compilation process works in Go. First of all, we can build some kind of binary file from this application. In this case, I will use Go build. Okay, so as you can see, I have a binary file that works with my operation system that I can execute as just a simple application, which is actually do nothing. So we have no output here. Also, guys, I can compile this application into assembler. Like in this case, I will pass the S argument to my application. Let's do this and let's check the result. You see, here is a file main.assemble. That means that here we have some kind of assembler code of my application. And let's check how does it works. First of all, here is some kind of entry point of my application, and here is a place where it's do return. In this case, return means exit. And func data is a kind of commands for garbage collection. As you see, while I have only a few lines of code in my source code, here in assembler it is even less. And the funny moment is that Golang is a compiled language. And here, guys, you see that this application do actually nothing. It is do nothing because here we do some calculations, okay, b plus c, 2 plus 2, but we do not use the final result. And in this way, on a compilation process, compiler decided just to get rid of this code because it is useless. So it is do nothing. But to see real assembler code, we can disable optimizations on our compilation process. So I can do this. And in this case, I will have another assembler code that actually is like a machine code representation of my Golang application. So here you see the normal source code with English words like const means constant, main is like a main function, main entry point of our application. Like here is a variable and a human readable arithmetic operations. And here is a representation of a machine code with some mnemonic tags like subq, moveq, no op means no operations, and return, for example. How to read assembler? First of all, every assembler instruction has its tag, like a name of this operation. Like, for example, subq using for allocated some space on a stack, as I remember, and add q using to do like arithmetic operation plus. So it means that we need to add the variables that we have in two registers and save the results here. So it means that assembler is very easy to read, and every CPU has its own assembler, and there are only 200 or 300 of main instructions we can use. And when your application will panic, you will see the assembler code, the assembler representation of your application, where you can check some things, you can debug, and the main point is that you should not be scared to go and check these instructions. What does they mean exactly? They're very easy to read, like they're created for humans. So for example, add q is to arithmetic operation plus, and move q, it is a move qui, you know. So if you will check the documentation, for example, for Go assembler or for assembler for your CPU you use on your home machine, then you will be not scared about that. But for now, for right now, for programming machine lesson, you should understand that there is a few representations of your source code. So it is like human readable code, and it is a version of your code that understandable for machine. And it was about compiled programming languages, but let's go to interpreted. We talked about that Golang is a compiled programming language, so it means that we use a compiler that build binary files from our application. So OS then can be able to execute this application without any other steps. But also we have programming languages like Python, PHP, Java that is actually interpreted programming languages. What does it mean? It means that more or less there are no compiler. There are virtual machine or interpreter. It means that what was the goal? The goal was to write application once and run everywhere. Um, for doing this, we need some kind of emulator, virtual machine that will know how to translate our, for example, Python source code to machine commands. And yeah, in this case, it works like this. So interpreter will read the application line by line and will translate this application to a machine commands line by line. Comparable to Go, where like we have already did all of this action and we have just binary. In Python or Java, we need a virtual machine to control the memory state, to translate the source code or bytecode into machine commands, okay? And comparable to Go, for example, this application looks slow because we have a big angry virtual machine. We do a translation of source code into machine code commands like line by line. What it gives us some level of flexibility. So in this case, we have a Python console, for example, where we can execute the application line by line, do our experiments, debug, find the best point to express our logic into code. So yeah, it is like two different families of programming languages. It is compiled and it is the programming languages that use the interpreter to run. And here guys, you see some kind of list of types at different programming languages. And to be an educated software engineers, we need to remember all of this. First of all, the first thing is that we can describe programming languages as a low-level languages like a machine code, for example, middle level like assembler that use mnemonic tags to show us some machine instructions. And it is a high-level languages that actually use English, okay? Like Java, Go, PHP, JS, and many others. Then there is some explanation of programming languages according to its, I would say, usage style. Okay. First of all, we have like object-oriented languages where we always use object to describe a state of our application, yeah, or we use functional languages where the main unit is a function, so we can use functions as arguments for another functions. We can use clean functions, etc. So if Java, for example, is object-oriented language, then Haskell, for example, is a functional language where we have immutable data where function is our all, and even variables is more or less function that always return a constant. Or, for example, script programming languages like a bash. So it is simple, but it is just works when we need a scripting. Prolog is logic programming, like programming logic, Prolog. It seems that we do write our application as a subset of facts, and then application can answer some questions. I will show you a link to some kind of Prolog tutorial. So it is very interesting, and you will be surprised if you will go through the logic programming. And finally, there is a procedural programming languages like C. where you have no abilities to do a functional programming, you have no abilities to do to use like everything as an object, but yeah, somehow Go has yeah, gives us ability to use procedural style, object-oriented style, functional style, not really like very advanced features, but the beginner's set, yeah, it is possible. Then programming languages has different typing system. For example, strong typing and weak typing, static typing and dynamic typing. What is the difference? The difference is that in the strong typing languages, we cannot mix a few different types in one expression, for example. For example, we cannot write 2 like number 2 plus string with char 2 because it is the different types, so we cannot use different types in one expression. For example, we cannot use a string type as an argument if function expect like integer data type. Okay, then weak typing is like GS. In GS we can exactly do like a 2 number plus string 2, and it is like absolutely valid expression, so you can try. Then static typing and dynamic typing. Static typing is where all types application know the type of every variable on compile process, and dynamic typing is when application do a type check on runtime. Then about memory management, guys. First of all, there is three types of programming languages according to how do we manage a memory there. First of all, it is manual memory management, like C and C++. If we need some space, we call a function where we ask operation system like gives us space enough for this variable. Or we can use a garbage collector, which is some kind of automatic memory management. For example, it is like Java and Go. We can just create a variable. We do not care about when and how this space will be allocated, when we do deallocation of this space. It is because of we have garbage collector that care about this part of our job. And then it is Rust lang. Rust lang do not use garbage collector, and Rust lang do not allow us to allocate or deallocate memory. So in Rust, you write application in some specific manner when compiler able to put allocation and deallocation commands on compilation process. So again, a few types of programming languages according to its level, low, high level, or middle, etc., or according to some kind of programming style, which is procedural, object-oriented, logic, scripted, and functional programming languages, or about how do type organize there, like strong typing, weak typing, static, and dynamic. And according to memory management, it is a manual or garbage collector or Rust lang. So let's go to the final step about programming machine. When you will be a backend developers, you will probably use some kind of cloud platforms like Google Cloud or AWS or DigitalOcean, etc. And then you will choose a machine that exactly fit your needs. And you should remember that like according to this lection we had, there is a CPU, memory, and disk. And according to these three main things, you will choose a machine that has like better CPU and for example more or less slow disk. or for example big amount of random access memory, but not really big amount of disk. Because if you need to locate some kind of HTTP server on this machine, you need one kind of machine. If you need to deploy some long-term storage database, it will be another kind of machine with probably very quick disk like SSD, okay? Or for example, if you need to create some cold storage for your files, okay, for example for photos, you do not need very cool CPU or blaze fast disk, okay? So you can save your money and money of your company by using actually just a hard disk to save your files. Then it is a different CPU architecture, guys. Maybe for now it is not really super clear for you, you know. But in the next steps, in the next lessons, we will do compile the Golang application for different CPU architecture, and I will show you how does it works, how to compile, etc. And the final things is about monitoring of your application. It is a very common mistake of junior developers when they just create an application and do not think about its monitoring. That is very, very important. Golang has like some kind of built-in metrics, but in most of the cases you will check three of them. It is memory as amount of random access memory, virtual memory is available for your application. It is a disk if your application do write some logs or files, and it is a CPU because if your application go out of CPU, then it will be not really cool for you to run this application because it will go very slow. And here guys, I have a few links for you and a few small tasks that you can go to be ready to the next lessons. First of all, the first link, it is about assembler. There are very detailed explanation about how does it work and how should we understand that. Then medium.com, it is a very nice article about like you can read to understand how machine works better. Then guys, very soon we will start Go development. So the third link is about how to install Golang. There is tutorial how to do that for Linux, for Mac, for Windows. So you will have no problems, guys. Then numeric system. You should watch a video, so there is explanation how to translate between different numeric systems, so it will be easy for you. And then guys, an advice: if you still use Windows, stop that please. As a backend developer, like to work with Go, you need Mac OS or Linux. I use Mac. You can just install Linux, because experience with these types of operation system is very important for backend developer. So please find a way to use Mac or Linux if you still do not do that. Thank you guys for watching. Have a nice day. On the comments to this video, I will add links to my Instagram, to my subreddit where we have a Golang backend learning course, and to my Patreon for donations. It was a big pleasure to do this content for you guys. Have a nice day and happy coding. See you soon.